Number 1, evaluate each of the following sums. So we switch gears today to look at series. And series are when you add up a bunch of terms in a sequence. And we use this summation notation here to add up these sequences. It's called sigma notation sometimes because this Greek letter here, this capital Greek letter here, is a sigma. And here's how sigma notation works. This index, so our index variable is I, and it says start by plugging in a 2. So I'm going to start by doing 4 times 2. Then I keep plugging in the next integer, so the next integer I'm going to plug in is a 3. And I keep doing that until I stop up here. So 4 times 3. Great, keep going. Now I'm going to plug in a 4, 4 times 4. I'm going to plug in a 5, but I don't keep going because it says stop at 5. So we get 8 plus 12 plus 16 plus 20. 20 plus 20 is 40 plus 16 is 56. So you could use your calculator there to add those up, but if I add up the terms here, I get 56. For this next sequence, I'm starting in by plugging in a 1 for k, so I get 1 squared plus 1. I take that, and I add it to, well, I go to the next integer, 2 squared plus 1. And then I go to the next integer, 3 squared plus 1. But I'm stopping at 4, so I still need to do a 4 squared plus 1. 1 squared plus 1 is 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. 4 squared plus 1 is 17. When I add all these numbers together, I get 17 plus 17 is 34. So this sum, this series here that I wrote out is really 34. The sum of that sequence, 2, 5, 10, 17, is 34. On your TI-84s, sorry TI-83 users, under math, all the way at the bottom, you see 0, which is summation and has the sigma there. We can type in, let's do this last problem. X equals 1. We started in by plugging in a 1 for our index variable. We went all the way up to 4, and the function or the sequence was k squared, x squared plus 1. Enter, 34, just like we got. So you can use your calculator to check your summations here. You can use your calculator to check your summations. This next sequence, I'm going to start by plugging in a 0. I'm going to stop at 3. So I get negative 4 to the negative 2 plus negative 4, what comes after 0 is 1. 1 minus 2 is negative 1. Now I'm going to plug in a 2, and I get 0 plus negative 4. When I plug in a 3, I get 3 minus 2 is 1. Negative 4 to the negative 2 plus negative 4 to the negative 1 plus negative 4 to the 0 plus negative 4 to the 1. So I have negative 4 to the negative 2. Make sure you're using parentheses here. Make sure you're using parentheses. Plus negative 4 to the negative 1 plus negative 4 to the 0 plus negative 4 to the 1. And your sum is negative 3.1875. This sum comes out to be negative 3.1875. And finally, the last one. We're going to plug in a 1. I'm going to plug in a 1 to this expression here and get 1 times 2. I plugged in a 1, so now I go to the next integer. I'm going to plug in a 2 for n. 2 times 3. Plugged in a 2, now I'm going to go up and plug in a 3, and I'm going to stop. 3 times 4. So 2 plus 6 plus 12 is better known as 20. And you can check those two using your calculator if you have a TI-84. So summation notation, the big idea is this index down here tells you where to start. Plug in a 1 for n. This tells you where to stop. Write each of the following sums using sigma notation. So I want to represent this sum here using sigma notation. So negative 2, 4, negative 8. Looks like the pattern is multiplied by negative 2. So I have a common ratio of negative 2. So to write an explicit formula for this, that's negative 2. It's my first term times negative 2 to the n minus 1. My index, my first term is negative 2. That's my second term. That's my third term. I need to figure out what is 128. So the pattern is multiply by negative 2. Negative 8 is the third term. That's the fourth term. Fifth term. Sixth term. Seventh term. So negative 128 is the seventh term. So the index up there is 7. This sum here will represent that sequence. This next sequence, 4, 9, 14, this has a common difference of 5. I keep adding 5 on here, so this is an arithmetic series. This is a geometric series because these terms form a geometric sequence. This is an arithmetic series. So what's the formula for this? 4 plus 5 times n minus 1. First term plus d times n minus 1. Well, we know that 4 is the first term. How do I get all the way to 49? Well, you could sit there and keep on plugging in plus 5, plus 5, plus 5, or you could say 49 equals 4 plus 5 times n minus 1. That'll tell me the n value to put up there. Get 45 equals 5 times n minus 1. Divide by 5, and I get 9 equals n minus 1, so n equals 10. This is the 10th term in the sequence, so I'm going to stop at 10. This summation notation represents that sequence. Maybe you distributed that 5 to get 5n minus 1, and maybe that's what you put in there. But it doesn't matter, they're equivalent, so it gives you the same value. That was lesson 6. Hopefully sigma notation seems scary at first, but it's actually not that bad. It's actually not that bad.